Oh, good afternoon, everyone. I want to welcome you to another week. But before I go into the new topic of the day, I'll for discuss about the midterm two results. Let me say that students wrote this exam at different times. The first set of students that started the exam, I actually get kind of feedback from them about question 20 and question 21. Now, because of the, I noticed there was a typographic error in the question 20, and I saved that, and I did not know the computer did not really save good when I was setting the questions. And when I realized that, that was in the middle of the exam. So I corrected that. But those who have already submitted, that will impact their results. And that was why I took a decision. Okay. And the decision I took was to give everyone a full credit for question 20 and question 21. That was so if there is anyone uh, you know, who did not get a full credit, like the way I program it after whatever answer you choose for question 20 and for question 21, of course, you're actually going to get it right. Yeah, go ahead.
Are those the questions on variance?
Yeah,
Okay.
so that's the question on variance. I think that was a kind of. So if you notice in your score, okay, if you notice I regraded. Okay. Now, those who choose correct answer after I've, there are some people that choose the correct answer after I've re-edit it. Of course, but to be at the safer side to everybody, to those who have spent time on the question 20 and 21. So the only thing I would do, since the mistake is from me, okay, because the computer didn't save good, then I have to give full credit. So if you check your result or you check it and you realize that you did not get a full credit for 20 and 21, please make sure you write me. Okay? Does that make sense? But the solutions to the exam will be released tonight. Even though some of you have seen, the from the feedback of the answers, but I still got to make sure you get the solution tonight. The final thing I'm going to say before I start showing the analysis of result, of course, final exam is written in person in this class. I think you already know about it. Go ahead. Can you say that again? Not really. It's just the one I'm going to post tonight is where I just pick the correct answers. But maybe by the time we're preparing for final revision, I'm also going to make a video for that. And my lecture from now, like I said, be recording that and be sharing that on the YouTube, for you to have opportunity. Now, this is the histogram of the score, the midterm two results, which trying to tell us it is not normally distributed. When it is not normally distributed, if I want to talk about average, I'm going to be using median instead of mean. Okay? When you have a skewed distribution, okay, and you want to talk about the measure of location, then you are not going to use mean, but you're going to use median. So which means the average performance in this class for midterm two is 86 point. Go ahead.
I just wanted to ask, when will the practical assignment be released?
The practical assignment is the last assignment. Oh. That was why I didn't mention, the last assignment you're going to have, I will make it a practically based. Does that make sense? It's not as if you have a special practical assignment. It's going to be the last assignment. Okay, so this is the median, the performance in midterm two. That's 86.80. You can see the minimum and you can see the maximum. Okay, so not too bad, but I'm hoping that the median performance in the final is likely going to be 99, which is possible. Now, when you're going to be in person, okay, you're going to be here in person writing the exam. But we have started again, and I need you to pay attention. This is being recorded. Like I said, okay, I'm going to share that on the YouTube. Now, let's get started with today's. Now, the other time, before we go on break, was it break? Oh, sorry. Let me just say before the midterm or two, we started one sample estimation, okay? And of course, we're going to continue from that. That's why I'm calling this part two, where we're going to talk about one sample estimation and two sample estimation, okay? Now, in the outline, I'm going to walk you through how do we estimate the difference between two means, okay? Then we're also going to have inference on proportion. Like I said, this is a countdown to the final. Of course, you know, our final has a huge weight. We advise that you pay attention. Okay, I like the way that was improvement in the midterm 2 result compared to midterm 1. And I'm also anticipating a highly significant improvement in the final as well, because the final has a huge weight. And the countdown starts now because all the topics we're going to be doing from now, they're going to be in the final. Does that make sense? They're all going to be in the final. Okay, now, go ahead.
So the final, like cumulative, or it's just stuff that we covered?
The final is going to be cumulative, but the topic we started like estimation, the one we started last week, is going to take like 60%. I'm going to give the distribution the way it's going to, but whatever we're going to be taking now, why I'm going to put it at 60%, because it's still going to be fresh in your memory. Does that make sense? Okay, now let's start it again. Now we want to start two samples, estimating difference between means. Now, let me tell you this. We're talking about two samples, okay? We actually want to know, is there a significant difference between two means? Want to know the difference between average annual deposit, or let me just say, in two different banks. What is the difference? Maybe I'm talking about West Fargo or OTT Bank. Can we compare the average deposit in the two banks? Can we compare, the means of two independent groups? If we want to do that, we need to first ask ourselves, okay, what kind of estimation are we talking about? We got a point estimation. The point estimation, give me 1 second. Let me see if this guy is going right here. The point estimator is this guy. If you take a look at this guy, you know what that guy is telling me, right? That guy is just telling me, find the average, get the two average, subtract them. That's all. That's what we call a point. We call that point estimate. Okay? We call that point estimate. We call that point estimate. But you know what? A point estimate could be wrong or right. The probability that it's going to be wrong is 50%. The probability that it's going to be right. So that's too dicey. And because of that, we needed to incorporate margin of error. We needed to incorporate margin of error. Okay? Now, by margin of error, it means instead of us to focus only on the point estimate, we want to focus on the interval estimate. Now, if you take a look at this guy, now, right, and this guy here, you're actually going to see that I'm subtracting, at this end, I'm subtracting this guy from the difference, and here I'm adding that to the difference. and with the belief that what is the true mean of the difference? The true mean, this, if you take a look at what you see here, this is the true difference of means. The true difference of means. The only way we're going to get this guy is when we study the two population entirely. We do not have resources for that. If I want to compare the standard of living in two countries, I do not necessarily need to study every income earners in the two countries. If I study every income earners in the two countries, then I'll be able to get this guy. Okay? But we are not going to do that. We're limited by budget. And what we're going to do at the end of the day is to take a sample, independent sample from the two countries. And at the end of the day, when I take independent sample, when I find this guy, then I also need to find the margin of error, where I'm actually going to subtract the margin of error. I'm going to add the margin of error. If you take a look at the idea we're using here, we are actually using the idea of a sampling distribution, believing that this guy follow normal distribution with the mean of this and the standard deviation of this. So that is the belief. So this guy here followed normal distribution. By sampling distribution that we did the other time, we realized that this is a random variable. It followed normal distribution with the mean of this and the standard deviation of this. And that was why this guy, the standard deviation of that is what you see here. You see that? That is what you see here. That is the standard deviation of the difference of the means. Okay? And what you see here, the Z alpha over 2 is what we're going to check from the Z table. We're going to check that from the Z table. And of course, if you take a look at, then I'm going to walk you through an example on how to use that. Take a look at this example now. A study was conducted, okay, in which two types of engines, A and B, were compared. We live in a world where we always compare. Why do we compare? Because there's a variation in the world. Does that make sense? So that is called for comparison. Okay. Now, gas mileage in miles per gallon was measured. 15 experiments was conducted using engine type A, and 75 experiments were done with the engine type B. Okay, the gasoline use and other conditions were at constant. The average gas mileage was 36%, miles per gallon for engine A, and for 42 miles per gallon for engine B, find a 96% confidence interval on this. The other time I was using mu1 minus mu2, okay, which we can use A and B. Does that make sense? Okay, now where that and that, represent the population mean gas mileages for engine A and B, respectively, assuming the population standard deviation are 6.8 and 6 and 8 for engine A and B. Now, I need you to listen now because of the purpose of final exam and when you want to conduct research. Take a look at this formula here. Now, the formula here, give me 1 second. The formula here, you will notice in the formula, there's a Z score, right? There's a Z, okay? We use this formula only if the population variances are known. There's a difference between population variances and sample variances. Does that make sense to everyone now? Okay, when the population variances are known, I'm actually going to use a confidence interval that's actually centered on Z score. Because we also have another confidence interval that's centered on T score. With this Z and T, okay? But when the population variances are known, that is, you're going to be given, okay? Then we're actually going to use this. And when you take a look at any question, if you take a look at this, assuming, okay, the population standard deviation, which means they are given. The moment you have population standard deviation, you also have population variances. Okay, now, if you want to construct now, take a look at what I'm doing here. Okay, I got 6 through this. 6 is the point estimate of the difference. You got 6 by subtracting the means the sample means, okay, because they told us they're looking at the true difference of B minus A. That was why it's going to be sample mean for B group minus that of A. Does that make sense? And this actually give us 6. This very 6 here is a point estimate of the difference of means. Okay, now if I have a 6, then what do I need to do? Now I need to compute the margin of error. Now, when you take a look at this, the 64 here is sigma 1 squared, which is the variance. Okay, how am I going to get the variance? You are already given the population standard deviation. You're going to square each of these. Squaring 8, 64, squaring 6, 36. Okay, and of course, they told you the number of sample choosing in the first group. Okay, and the number of sample choosing in the other group, you can see they conducted 75 experiments and 15 experiments. And how am I going to get 2.05? Of course, I will need to go to table. I needed to be focused on how I'm going to get 2.05 from the table. Of course, they say 96%. Now, when we have a 96% level of confidence, then what is going to be alpha? Okay, alpha, which is the level of significance, will be 1 minus level of confidence. 96% means 0.96. What is 1 minus 0.96? That would be 0.04, right? Then you divide that by 2. When you divide the 0.04 by 2, what do you have? 0.02. So which means I'm going to go to the Z table in table 8.3. I'm actually going to check for a value. So that will give me 2.05. And at the end of the day, when I calculate that, then what is the meaning of this guy? It means after I'm done with this give me the lower bound of 3.43, and this guy gave me the upper bound of 8.57. What am I going to tell the world here? So what does it mean? So what the guy means is we are 96% confident. You're actually going to quote, when you are interpreting this, you needed to quote the level of confidence given. I'm going to say we are 96% confident that the true difference of means, lie between this guy and that guy. I'm done. The true difference of me, this guy, mu b minus that is the true, this is what I mean, true difference. Okay, true difference, okay, of means. Okay, the true difference also, true difference of mean, it also means population, the true, the population mean difference. Okay, that is what it means. Okay, or you say the difference of population means. Okay, that is the true difference of means. So we want to interpret that. You actually are going to quote the level of significance. Okay, so take a look at what we have now. Is there any question about that? Is there any question? Like I said, the final start now. Final exam starts now. Okay, the topic we're doing now that we're going to be doing, okay, it's actually going to contribute 60% to the final. And final has a huge weight. Okay, so please pay attention now. Is there any question about this guy? Is there any question? Okay, now I'm going to move. There's no question. I'm going to move. Now, what of in a situation where the population variances or the population standard deviation are not given? Okay, if the population variances or population standard deviation are not given, then we actually need to pull the variance. We need to pull the variance. We use the idea of a pulling variance if we are not given the population variances or population standard deviation. Now, when you take a look at what I circled now, you're actually going to see x1 squared and s2 squared, right? Those are the sample variances. What are we pulling here? We're pulling sample variances. N1 is the sample size taken from the group 1, and N2 is the sample size taken from the group 2. Now, let me now walk you through a problem where you actually, let me now show you what the formula, oh my God, take a look at this formula now. It's a little bit different from the one we used the other time. Pay attention here. This is used when you want to construct a confidence interval, okay, for the difference of means when the two population variances or the two population standard deviation are not given, but they are assumed to be equal. Take a look at that. But both unknown, but when they are unknown, we also assume that they are what? Equal. Does that make sense? That is where we use pool variance. They are not given. An assumption is that since they are not given, they're going to be equal. Then we're going to pull the variance. No, I need you to pay attention to the formula right now. Okay, the only difference you're going to see in the formula right now is, initially, when in the other one, you saw a sigma 1 square, sigma 2 square before, right? But right now, it's going to be replaced by the same SP, SP squared. What is it doing now here? If this SP is inside the square, it's going to be SP squared. Does that make sense? So we've taken the square root. Now the XP here, okay, the XP, okay, that you see, this is how we're gonna compute the SP using that. When the four of us get the SP out, you get the SP squared. Okay, after whatever you get there, if I want to get SP, I'm gonna take the square root. Okay, now let's solve a problem that's gonna look like, and let me tell you this. When you're using this, we are not going to check from Z table anymore, but we're going to be checking from T table. Okay, we're going to be checking from T table, and if we want to check from T table, we need a degree of freedom. We're checking from a normal table the other time, we did not need any degree of freedom, but right now we need a degree of freedom. Then the degree of freedom is this guy, N1 plus N2 minus 2. That will be the degree of freedom, V. Okay, now let us solve a problem. Let's solve a problem right now. Now, there's an article, okay, and this was published in the Journal of Environmental Pollution. Okay, so now I'm going to give you the question. What is the question about? Let's take a look at this. Please, I need you to focus more on the board. 2 independent sampling were chosen for this study, one located downstream from the acid mine, the charge point, and the other located upstream for 12 monthly samples collected at the downstream station. The species diversity index at the mean of that. Okay, when you see a mean of that, that's a sample mean, right? And the standard deviation, what do you see? X1, that's a sample standard deviation. Okay, that's a sample. If you see a sigma, let's say if you see sigma, that's a population standard deviation. If you see sigma squared, that's a population variance. Okay, so what I mean, this is population standard deviation. Okay, so this is population variance. Okay, the way you see this guy now, this is sample variance. When you see this guy now, this is sample standard deviation. So I need you to pay attention to notations. Okay, now, right now, of course, there's going to be a sample standard deviation from the first group. Okay, now you give it for that, and they ask you, find a 90% confidence interval for the difference between the population mean for the 2 locations. Now, pay attention now, assuming that the population are approximately normally distributed with equal variances. Equal variances. When they say equal variances, they are referring to the population variances. And I told you, when the population variances are the same, okay, and they are not given, we're actually going to make use of the pool 1. Okay, now this is the solution now. if you want to solve the problem in the exam, don't forget the exam is going to be the final exam. It's going to be in person. You're going to be given document. You're going to write, like a traditional exam. If I want to solve the problem, oh my God, this is the step. What am I going to do first? I'm actually need to find a point estimate. Okay, when you take a look at this guy, what am I doing there? I'm subtracting the two means given. Okay, subtracting the two means now. Okay, we got 1.07. The next thing that I'm actually going to do is to figure out, okay, the pool variance. I need the pool variance. Okay, now when I'm figuring out the pool variance, I'm actually going to substitute. I'm trying to say, for me to have 11 here, it means the sample size for the first group was 12. For me to have 9, the sample for the second group was 10. And of course, you can see this guy, that is in squared. It means we're squaring the sample standard deviation divided by N1 plus N2 minus 2. And after that, I got the sample, the pool variance. Okay, so after getting that, so what is going to be the next thing that I'm actually going to do now? Okay, now, how do I know alpha is 0.1? Because they mentioned 90. I needed to listen now. In the question, they mentioned 90%, right? When you have a 90%, that would be 0.9. What is 1 minus 0.9? Okay, 1 minus, that would be 0.1, right? Okay, that was why alpha is 0.1. Okay, now the moment you get alpha to be 0.1, then you needed to do alpha over 2. Don't forget, always going to do alpha over 2. What is 0.1 divided by 2? That would be 0.05, right? Now it means if I want to go to t table now, if I want to check for the t value now, I will need to check under the level of significance of 0.05 against the degree of freedom 20. Okay, if you go to the table, did I share the table right here? Okay, so if you go to right here, table A.4 in the textbook, if you go there, you're actually going to see the table I'm not talking about. So when you look at that, you're actually going to get 1.725. You need to be able to check that correctly, okay, because that could impact your result. Now, 1.2725 is what I'm going to put in place of a t, okay. You're actually going to see that in place of a t, okay. And of course, after putting that, what is the 0.646? That was the square root, the square root of this guy. I got this guy to be this, right? So what is the square root of that? Of course, SP is going to be 0. When you find the square root of this guy here, it's going to be this guy. That's what I put here. That's what I put in. All we just need to do is subtract from the difference, then add to that, and finally, I got this result. So finally, this is what I got. Finally, okay. Now, how do we interpret this? You're actually going to say, we are 90% confident. Don't forget, whenever you want to interpret this guy, you need to refer to the level of confidence given. So you're going to say, we are 90% confident, okay, that the difference, of the true difference of mean lie between this and this. So mean of what? If you really want to know, okay, means of what? You can go back. If you want to be precise, okay, if you really want to be precise, you can actually come back here, okay. They say find 90% confidence interval for the difference between the population mean for the two locations, okay, for the two locations. So definitely you are trying to say that you are 90% confident, okay, that, the difference of mean, the true difference of means for the two locations is actually going to lie between this and this. Okay, any question about that? The same way we interpret when the population variances are given is the same way we interpret when the population variances are not given. The only difference between them is what we make use of. In one, we make use of a t-score. In another one, we make use of a z-score. And where you are supposed to make use of a z-score, if you make it of a t-score, of course, you're not going to get it right. So you got to make sure you use an appropriate formula for a given situation. Okay, we have another one. We have another confidence interval. Okay, for what of in a situation, I need you to pay attention to this guy. Okay, the two population variances, they are unknown, but they are not assumed to be equal. Take a look at this. They are not. We don't know them, and we don't assume them to be equal. You know, the first one we did, okay, we know them, right? We use Z. The second one we did, we do not know them, but they are assumed to be equal. They're going to tell us in the question. Does that make sense? Now, the third one we want to do now, they were not given, but they are not assumed to be equal. Now, we're still going to make use of this formula. If you take a look at this formula now, it is very similar to the first one, except that the sample variances now replaces the population variances. Not only that, instead of having a Z, we have a T. Look at the third one. Do you see the third one? Okay, now, the only difference between this one now and the second one that we did is that the degree of freedom will not be the same. In the other one, the second one that we did, the degree of freedom was N1 plus N2 minus 2. But oh my God, I need this to get the degree of freedom. I need this guy to get the degree of freedom. Okay, and in all of this, all what I just need is, this is one of the reasons why you do algebra in high school. I remember when you're doing algebra in high school, they're going to give you evaluation of a function, or you simplify stuff like that. If you take a look at what you have here, you only need sample variances and it's two samples. The moment you do that, you're going to get your V. That will be the degree of freedom. You're going to check in the T table. Okay, so that's what you're going to do here. Now, without wasting my time, I'm going to go to another one. Now, I need you to pay attention now. Okay, we want to talk about paired observations. The three scenarios that we did, we call them difference. We call them difference of means. The three scenarios that we just did, difference of means. When do we normally talk about difference of means? Oh, we talk about difference of means when we have two independent groups. The three that we just did now, the first one, the second one, the third one, assumption is that the two groups we're comparing are independent. But the one we want to start now, we call that mean of the difference. Mean of the difference is different from difference of means. They are not the same. Now, in the mean of the difference, it means after finding the difference, we now find the mean of the difference. And this is used for two dependent groups. There's a difference between independent group and dependent group. Let me tell you the meaning of this. A particular company, right? They want to improve on productivity. And you know what they did? They decided to give their workers incentives. Okay? They decided to give their workers incentives. They now want to compare productivity before they gave them incentives and after giving them incentives. Why is it that the two groups are dependent? Because it's the same workers. Does that make sense? It's the same workers. It's like comparing the performance, maybe me now, okay, this is my performance before giving incentives. This is my performance after, because they are still using me, then that is a dependent. That is not independent. And that kind of observation is going to be called paired. observation, which means they're actually going to be visiting a participant in more than one occasion to collect data. Does that make sense? That's what we call paired observation. Now, right now, if they now, in that situation, they are seeking to get this guy. Mu D that you see, mu D, is actually going to be called the mean of the difference, which means we're going to get, let's say we are all workers now, okay? We're going to come to this guy. We're going to collect the performance before incentives and after incentives. What are we going to do to this? We're going to subtract, right? We have one value. We do it to this guy. If we have 1,000 employees, we do how many differences are we going to have? 1,000 difference. What are we going to do to the difference? We find the mean of that, average of that. When you do the average of that, that is going to give you this. You know the meaning? D is the difference. Putting a bar on the difference means mean of the difference. Does that make sense? Mean of the difference. When you have a mean of the difference, then the next is, because we cannot trust a single value, we needed to create an interval. We need a margin of error. The margin of error now, oh my God, the margin of error now is this guy here now. Take a look at that guy. Oh, what are we using here? Then we are taking that guy, is a D bar. You remember sample mean, right? You remember the idea? They're using the idea because we're talking about D bar. You remember when Y followed normal, we got this and this. What about Y bar? The Y bar is going to be this. You see that? But because D, we're talking about D bar. So it's going to follow normal with the mean of this guy. And the standard deviation is going to be this. That's why you see SD. So the D here is telling you, if I can find the mean of the difference, I can also find the standard deviation of the difference. Does that make sense? If the difference become a random variable, and I can find the mean of that, I can also find the standard deviation of that. Then from there, then I'll be able to use the, the formula on the board. But you know what? The PRT test, we call this a paired observation, interval, this is an interval estimation for the pair, okay, which for the dependent group. Now, we're always going to make use of a T-score. Don't forget, if I want to make use of a T-score, if I want to check from T-table, I need a degree of freedom. How are we going to find degree of freedom here? It's just going to be n-1. Please pay attention to how we find the degree of freedom. The formula that I give out, I've given you, different way, like different formula of how to figure out the degree of freedom. Now, you know what we want to do now? Let's go into question. Oh my God, take a look at this question now. Okay. Oh, why is it dependent? Why is it dependent? We're using the same veteran, but at two occasions. Let's take a look at it. A study published in Chemosphere reported the level of the, give me 1 second. Is that saying my battery is low? Give me 1 second. What's going on here? But I'm charging it. Give me 1 second. Because it's telling me my battery is low, and I'm charging it right here. Let's plug into, that's what I do. Okay. Let me do this. Let me put this on here and put that one here. And let's see what is going to happen. Okay. Let me see. It's just showing that. Okay, I think I'm going to quickly. Let's see what's going to happen. Okay, now let me go to. Okay, take a look at it. A study published in okay, the that's gone, and I have a charger here, so I don't know why. Let me quickly change. I think I got a backup, so it's not charging. So I don't know. Get it back up. Sorry about that. How do I bring the other one? Yeah, I don't understand. That's why it's good to have a backup, you know. So what I'm trying to say in essence is recognize when you're actually going to use the period, the one that has to do with period, okay, and the one that has to do with the independent rule, okay. One is coming out. Okay, you know, okay, come on, okay. Then I'm gonna go to the next one. Yep. Now, when you take a look at TCDD levels in plasma and TCDD level in fat tissue, they collected these two from the same person. That is why the two group is dependent. Does that make sense? Because it's the same subject. Now, if you take a look at this, we only focus on how many veterans? 10. Then we know what we're going to do now. Okay, we're going to find the difference. This DI here is just this minus that. Does that make sense? Now, if you take a look at this difference now, I think we have like 20. Yeah, we got 20 veteran. How many differences are you going to have? Going to be 20. Any question about how you get a difference? After getting the difference, if difference become a random variable now, okay, we need to find the mean of that, the standard deviation of that. Go ahead.
For this one, why is it -1?
It's just sample size -1 for this one. Numbers, it's going to be numbers of veterans used -1. Does that make sense? Okay, now take a look at this. What am I doing here? Give me 1 second. So what am I doing here? You can even use a calculator. That's no problem. Okay. What am I doing here? I'm finding the standard deviation based on the difference. Does that make sense? Okay, we find the mean, we find the standard deviation based on the difference. Okay, and after that, we find the degree of freedom. The question you just asked now, 20 veteran -1, that would be 19. Then all what I'm just going to do, what am I trying to say here? Okay, now I want to start using this formula here. I want to start using this formula here now. D bar is the mean of the difference. SD is the standard deviation of the difference. Now, using the formula now, take a look at what I got. Okay, I've already substituted. Okay, this guy here is the mean of the difference. This guy here, the standard deviation of the difference, the same way you compute the standard deviation from data set. This guy, the sample size. This guy, what you check from the T table, under the degree of freedom, 19. Don't forget, the degree of freedom is just going to be the sample size -1. And at the end of the day, so I need you to pay attention to this now. Okay, now this line between negative and what? Positive. Now, when an interval lies between a negative and positive, which means there is possibility of what? 0 in the interval. Does that make sense? And if there's 0 in the interval, you know what that means? There is no significant difference. So that was why I said from which we can conclude there is no significant difference between the TCDD level in plasma and the mean TCD level in the fat tissue. Here we're just comparing the TCD level in plasma and the TCD level in tissue of the same person. And this test review, anyway, we use how many veterans? 20. This test review, there's no difference. There's no statistical difference. Go ahead.
Wouldn't 0 always be part of the confidence interval if you just increase the level of confidence?
It actually depends, but this is what we can say. When the lower bound is negative and the upper bound is positive, then the 0 is in the interval. If it's 0 is in the interval, no significant difference. But what if you have negative, negative, positive, positive implies significant difference. Because you can't have 0 in the interval of negative, negative and positive, positive. Does that make sense? And that is the reason why the takeaway here is that the confidence interval also do the job of hypothesis testing. After this chapter, we're moving to hypothesis testing, right? There's an agreement between a confidence interval and hypothesis testing. Because maybe what we are testing here, is there any significant difference between the TCDD level in plasma and the TCDD in tissue of veterans? And from what we can see here, there is no significant difference. Now I got 2 more slides. And I want to leave the derivation here. What of in a situation where we want to focus on proportion? Okay, we use proportion in statistics. When we are not interested in everything, we're interested in a certain parts, maybe certain characteristics of interest. For instance, I want to know what is the proportion of Americans that approve the job the president is doing, or what is the proportion of people in a particular country that have a disease. That's a proportion. Now, if you take a look at this formula here, this is sample proportion is only going to give a single result, which could be wrong or right. But we don't want to face that kind of situation where it's going to be dicey. We needed to incorporate, the margin of error. This is the margin of error now. Does that make sense? So whenever you are dealing with proportion, we always make use of a formula that involves z-score. We're not going to have a formula that involves t-score. Now let's go into the last page. Let's take a look at this. In a random sample of 500 families, owing television set in the city of Hamilton, Canada, it is found that X equal to 340 subscribe to HBO. The characteristics of interest here is the number of family that subscribe to HBO. So which means it is not all the 500 family that subscribe to that. Find a 95% confidence interval for the actual proportion of family with television set in the city that subscribe to that. What you need to first do, you need to obtain your sample proportion first, which is going to be the number that subscribe to the sample size. That gives us a 0.68. A 0.68 here is a point estimate. It could be wrong or right. Now, because of that, we need it to incorporate, if you take a look at this is the 0.68 that I talk about, okay? Because we're dealing with 95%, alpha will be 5%, divide 0.05 divided by 2, check from table, that will be 1.96. That is why you see this guy here. And of course, if your P is a 0.68, Q is 1 minus that. At the end of the day, see the result. Now, how am I going to interpret this? Interpreting this means we are 95% confident that the proportion of, the proportion of family in the city of Hamilton, Canada, that subscribe to HBO is going to lie between this and this. So what are you trying to say? You are trying to say between 63.91% and 72.09% in that city subscribe to the HBO. You don't just want to say 68%. Because if you say 68%, that could be misleading. Because a single estimate could mislead. And that is why a better way to describe our estimate is to use interval. That's going to be the end. Like I said, if you don't get credit for question 20 and question 21 in the exam, send me a message. Okay, make sure you stay safe. Now we love you day. Bye for now, everyone.
No, I mean, probably. Oh, just go.